Hi, so in this video, we're going to learn how to calculate the mean free path, which the mean free path is the average distance between two particles before they collide. Right, so it would be something like that. It would look like that, and this would be the mean free path. Right, so they're about to collide. And the formula to calculate this guy is lambda. It's equals to 1 over the square root of 2 times n times sigma. Okay, where n in this case would be the pressure over the K Boltzmann constant times temperature in Kelvin times T. And sigma would be the collision cross section, and can be calculated as pi times the diameter square. Okay. Also, if you plug in, an easy way to find the mean free path is to, if you plug in the n, you can simplify this equation as kBT over square root of 2 times the pressure times collision cross section. Okay, so now in this problem we are given the temperature in Fahrenheit, and of course we have to have that in Kelvin. So after you do some calculations and convert it into Kelvin, I don't know if you remember how we can do it here real quick. So first we turn it into Celsius, which is 71.2 Fahrenheit minus 32 times 5 over 9. And then after that you can add the 273.15 Kelvin, right? So essentially the temperature would be about 294.93 Kelvin. All right, so that's that. We can calculate the collision cross section. So we're given the diameter of nitrogen molecules. So then essentially you would have collision cross section be pi, or if you are an engineer you can say that it's 3 times 10 to the negative 10 meters. Just square that. Okay, so after you plug it in your calculator, you should end up with about 1.0986 times 10 to the negative 19 meters squared. Okay, so what else are we given? So we also given the pressure. So we're given in units of pascals. So we know that a pascal 5 P8. So we know that pascals are also, we can express that units of kilograms per meter times second square. Right, it's very important for you to know these relationships, because then it would make things easier when it comes to canceling things out. And I think that's all we need. Oh no, we need the Boltzmann constant, and you can get that from your book or from the internet. So the Boltzmann constant is essentially the KB would be about 1.38 times 10 to the negative 23 joules per Kelvin. And also, you know that a joule is equals to kilograms times meter square per second square. All right. So now what we can do is just to essentially plug and chug. So we plug in our values of all this mess. So you have lambda, it's equals to kVt, which is essentially you would have 1.38 times 10 to the negative 23 meters kilograms times meter square times in per second square times, let me open the parentheses here, then we multiply by per Kelvin, very important, times our Kelvin or temperature, which is 294.93 Kelvin, and that's all over the square root of 2 times the pressure. We said it was 101.325. Let's have that into these units here, meters 10 seconds square, and then we just multiply by the collision cross section, which we found that it was 1.0986 times 10 to the negative 19 meters square. Okay, that's a lot to write. All right, so at this point, you can plug this in your calculator, and you should find that. Let me see here. Let me actually plug in here. There's this. So you should end up that is about 2.587 times 10 to negative 7 meters. Okay. So this would be the mean free path before this particles collide. So real quick, you can just jump to the conclusion that this is the formula that you need to use if you ask to find the mean free path, and you know the pressure. It's very useful for you to know the units, because then they can cancel out. And I think that's, of course, the temperature in Stephen Kelvin. And I think that's basically it. So if you have any questions, please let me know, and hope you have a great day.